The diode is looks like this. When you giving the power supply at this, like you know that one positive terminal is connected to anode and negative terminal is connected to cathode. This diode is acting like a forward bias. In the forward bias, we can draw the equivalent electrical circuit. Like you know that one, it is going to be having the closed circuit, like you know that one closed switch, short circuit type. Then this one is the ideal. It means that generally for the ideal thing, let me consider VI. VI, if it is greater than 0 volts, then diode is acting like a short circuit, or you can say it is the on condition. Then VI is less than 0 volts, then you can say diode is open circuit. Then you can say this diode is in off condition. This one is the ideal behavior of the diode. Then practically, how you can draw this one? Diode, practical diode is this one. Like you know, VI if it is greater than V cutting voltage, then diode will become on, or you can say it is short circuited. Then VI if it is lesser than cutting voltage, then diode will become off. Then you can say it is the open circuit. What is that? This one V gamma, it is nothing but cutting voltage. What is this one? This one is the cutting voltage. This cutting voltage depends upon what type of diode you use. Generally, we have the silicon diode as well as the germanium diode. When you use the silicon diode, the cutting voltage is equal to 0.7 volts. When you use the germanium diode, the cutting voltage is equal to 0.3 volts. It means this one is the minimum voltage we need to be applied from the external power supply to make it to conduct. If you are not satisfied to provide this minimum voltage from the power supply, diode will become open circuit. This one is the scenario of the practical diode. How the electrical equivalent circuit for this one? Generally, you know that one, when the diode is forward bias, it is having the minimum cutting voltage need to be satisfied, then it is consisting of a short circuited switch like this. This is one practical diode. Next one is piecewise model. What is a piecewise model? The piecewise model means piecewise model. Same scenario, but we have to be include the resistance of the forward conductive diode. The resistance of the forward conductive diode. Here in this, in the previous one, you have not considered the resistance. In the ideal character, also not consider the resistor and cutting voltage. In practical diode, you consider the practical cutting voltage. In the piecewise model, you have to be consider the cutting voltage as well as the forward resistance. It means though the diode conducts fully, but it might have the small amount of resistance is available in the forward conduction also. The equivalent diagram for this one, generally, you know that one, it is having the cutting voltage, which is having the IF, that is the forward resistance, and which is having the closure switch. This one is the equivalent electrical circuit diagram of piecewise model. Now, let us move to the clippers. Generally, now we came to understand how this practical diode, radial diode can be considered to define the shunt clipper as well as the series clipper. Generally, let us take the shunt clipper. For the shunt clipper, let me consider we have the diode and we have the resistance. This one is R, and we have the input, that is the VI, that it should be a sinusoidal only, and we have the V1. Generally, we have the VA and we have the K, and the voltage at anode terminal, voltage at cathode terminal. Now you are applying the input voltage, that is sinusoidal voltage, and we have the input resistance, that is named as a R. Then you should be understand. Here VI is connected in parallel to the R and this one. It means R and diode is acting like in series with each other. These are going to be share this input voltage according to the voltage dividing rule. It means that the voltage across the R, then voltage across the diode is equivalent to the sum of them is equivalent to the input voltage. So you should understand, like you know that VA is equal IR plus VD. VA is equal IR plus VD. Then you should be understand what is the V naught? V naught is equal VD. Or else ORR you can be understand V naught is equal VI. VD you can be consider sometimes 0 because when cutting voltage is equal to, if you consider 0, the voltage drop across the diode is equal 0. If suppose if you consider the cutting voltage of the diode even, when you are understanding the analyzing this clipper, this VD going to be equal to the 0.7. If you consider the diode is silicon diode. Now let us consider how it is going to be behave. Generally, you know, if suppose consider diode is ideal. What is the ideal diode considerations? We are not considering cutting voltage. So, and we are not considering forward resistance. So, it's just like a switch on off switch. It may be closed circuit, it may be open circuit, depends upon the pH. So, when you are going to understand this, you have to be consider diode is ideal diode. In further step, to analyze more about this circuit, you have to be consider diode is a practical diode, where you have to be include the cutting voltage as well as the forward resistance. What is the reverse resistance of the diode? You may get this answer. What is the reverse resistance of the diode? It is open circuit, so it is having infinite resistance. What is the forward resistance of the diode? Basically, it is very small. Now, you should understand. Now we are considering the ideal diode. Ideal diode. What are the things need to be considered? By using these considerations, you should be analyze this cycle. When you are going to be get the output, when you are not going to be get the output. The condition is V naught Vi if it is greater than 0. What is 0 mean? 0 volts. Then diode will become R. R is can be considered short circuited. What is the output? When D is on or short circuited, V naught is equal 0 volts. Because when this short circuited, you are taking the voltage output across the diode. But diode is short circuited, there is no resistance, so there is no voltage drop across these components. So what is the resultant output? Is equal to 0. When VA is greater than 0. This is first condition. But second condition is, if suppose VA is less than 0 volts, then diode will become off. Then it is called as an open circuit. Okay? What is the V naught? V naught is equal to VI. V naught is equal to VI. Obviously, because this is going to be open circuit, which is going to be open circuit. V naught is directly proportional to the VA. Nothing more than that. Means V naught follows the VI. Because this is open circuit, you are connecting the voltmeter here and it is going to be measuring this input voltage. Here also you could have some doubt about this one. Sir, we have the resistor here. Why don't you consider the drop of the voltage across the resistor? The thing is, this voltmeter is connected from here to here. It means though voltage is drop here, already it was included. This voltage is coming from the VI only. This total, these two components you are going to be considered to determine the V naught. What the V naught now? VI. Though if you have the voltage drop, from where it is getting the voltage? For the R, which is from the VI only. So this total voltage is coming at output terminal. This output terminal voltage now it is equal to the VI. when you consider the Vi is less than 0 volts. This is the understanding of the clipper. Then we should go the transfer characteristics of this clipper. What is the transfer characteristic? Let me take one graph. The graph is, we have the x-axis Vi and we have the y-axis V0. By using these conditions, we have to draw the graph. What do you mean by this graph? Vi means that here it is positive, this one is towards the negative. This is V0, it is towards the negative, this one is positive voltage. When it goes on increasing the voltage, what is happening? When it goes on decreasing the voltage, what is happening? We have to understand that. Then let me consider Vi is greater than 0 volts. It means that what coordinate this is? It means that this is Vi is greater than 0 volts. What happening? Diode will become on. Diode is short circuited. What is the output voltage? 0. Have you understood? What is the output voltage? 0. Then it means we should be draw the one line for this. Then this is diode is short circuited. So output is 0. The next condition, Vi is less than 0. Here Vi is, this is the direction of the concentration when Vi is less than 0. Then D is off. It is acting like a open circuit. What is the output? V0 equal to Vi. Where is the Vi? Here the Vi. What is the polarity of the Vi? Negative polarity. Because Vi, I am telling that one less than 0. What is the less than 0? Minus 1, minus 2, minus 3, minus 4, something like that. So it is a negative coordinate system. So Vi, it is a negative voltage, that is the minus. What is the corresponding output voltage? It is also negative because I stated that V0 is equal to Vi. When Vi is negative, obviously V0 also negative. V0 also negative. What is the slope of this one? V0 divided by Vi. It is equal to 1. What is the slope of this one? Equal to 1. What is the angle with this origin? It is the 45 degrees. Just it is follow the input voltage. This is transfer characteristics. We can derive this one. Transfer characteristics. Then you have to draw the waveform corresponding to this. How the input you are giving, how the output you are getting. Very simple. Generally, you know that we have the input. What is the input I stated? The input is sinusoid. Over the x-axis we have the t, over the y-axis we define that one is the Vi. What the Vi is sinusoid. In sinusoid, we have the positive peak, we have the negative peak. It follows the time. When time changes, amplitude of the signal is also going to be changed. Then, corresponding to positive peak, what's happening to the diode? Corresponding to negative peak, what happening to the diode? Already stated, when Vi is greater than 0, diode is short circuited, then output of the diode equal to 0. So 0. Because this is a voltage greater than 0. From here greater than 0 up to positive peak, then it is goes to the 0. Up to this total, this is the curve is going to be representing the positive voltage. When the voltage of the input is less than 0, then output follows input. This one. This is, can be note like this V0. This one is the input, this one is the output, corresponding to this diagram. This diagram. What the portion of the input is clipping? Positive portion. You can also name this one positive shunt clipper. It means that positive portion was clipped off, so that when you can say it is a positive shunt clipper. Like this. Next one, we can have the different variety of the diodes, clippers, and you can also reverse this diode. The diode also you can reverse. What happening here? Already stated, you know that one. When Vi is less than 0 volts, then diode is in forward bias. Why? Because you know already I stated when the diode is like this one is VA, this one is VK. Here let me consider we have a voltage applying like this. Positive terminal is connected to anode, negative terminal is connected to cathode. Then the diode voltage to the anode is more positive than the diode voltage which is going to be at the cathode is more negative or less negative, but it is comparatively with the anode it is having the less amplitude or less voltage when we consider. So the resultant VI, if suppose if it is greater than VK only, then diode will become forward bias. Otherwise, it is reverse bias. Then what is the configuration of the diode now? It is keeping very simple. Now diode is keeping like this. Did they change the input voltage? No. What is this one actually now? VA. What is this one? VK. Let me consider positive voltage applied to this one. Negative voltage up here we have the side voltage you are applying to this one. It means that when VK voltage is less than VA, as per stated equation that one, VA always should be greater than VK. When VK voltage is less than VA, the diode will become forward bias. When VK voltage is greater than VA, diode will become reverse bias. Now let us consider now VI less than 0 volts. You should be understanding less than 0 volts means corresponding to the VA voltage of this diode. 0 is corresponding to the VA. Then VI is less than 0 volts. Diode will become on. It is acting like a short circuit. Then what is the output? V0 is equal to the, when it is short circuit, what is the V0? It is 0 volts. Then VI greater than 0 volts, then diode is become off. Then it is going to be acting like a open circuit. What is the V0? V0 is equal to Vi. What are the transfer characteristics of this one? The transfer characteristic of this one is here we have Vi and we have V0. First condition, Vi is less than 0. Vi is less than 0. This portion. What happening? Diode is on and V0 is equal to 0. Very simple. Next one. Vi is greater than 0. What the portion need to be considered? This portion. Diode is on. It is going to be acting like open circuit. What is the output? Output follows input. What is the slope of this one? V0 divided by Vi is equal to 1. And one more point you should be remember. How long you should be extend this line over the x-axis, over the y-axis, something like this. This is the line you should be extending. What is this one? Negative peak. Up to what extent? How to extend this line? Positive peak. Where is the positive peak and negative peak? Because it should be understood right now. Here we have the time axis. We have the VM. And then this one is the input. Where is the positive peak? This one is positive peak. What is the negative peak? This one is negative peak. It means that your input voltage is rising to the positive peak, then it is goes to the 0, then it is goes to the negative peak, again it is come back to the 0. So, what is the maximum extension of the input voltage? Up to positive peak, or else it is up to negative peak. It means that diode will be acts according to the input voltage. How long it is going to be stay in the on condition, how long it is going to be stay in the off condition. It is depends upon the positive peak and negative peak. Accordingly, you have to be defined. Here, let me consider this positive peak is 1 volt. Let me consider negative peak is minus 1 volt. What is the voltage here? Actually, it is a 1 volt. What is the voltage here? It is a what is the voltage here? It is 1 volt. What is the output? It is the plus 1 volt. Because for the plus 1 volts, you will get the plus 1 volt output according to this diode action. Because when Vi is greater than 0, D is off, it is going to be acting like open circuit. V0 is equal to Vi. This is the input representation, and let me consider output representation. You have to take this dotted line to make you to understand this corresponding to the which off cycle is going to be effect of your diode action. For the positive off cycle means diode input voltage is greater than 0. What happened? Diode input voltage is greater than 0. What is output? Output follows input. It means it's simply replica of the input. It's no amplification function here. Next, when Vi is 0, less than 0, what is the output? It is 0. What the portion was clipped off? This portion was clipped off. Even output is like this is V0, this is Vi. Actually, input was having the positive cycle as well as the negative cycle. But output is going to be getting that one. Negative cycle is clipped off. What is this one? You can understand. What is the name you can give for this circuit? Negative clipped shunt clipper. Negative clipped shunt clipper. This is the understanding, basic understanding of the clipper. For this, again, you have to be improvised in many ways. In many ways, it can be improvised. How the one improvise for this configurations? You can be consider different components. Let me consider here. We have the diode. At the same time, we have the one reference voltage in series with the diode. How this clipper is going to be worked out? Generally, you know that one. Already I told you know that one. When you consider diode is an ideal condition, when Va is greater than 0, then diode will be acting like a short circuit, then output is equal to 0. When Va is less than 0, diode will be acting like open circuit, then output follows input. But it's not possible right now to consider like that because you connected one reference voltage in series with the diode. Then what to do here? For example, here what to do here? Here means Vi should be greater than VR. Where the VR was connected? Here at this point. For the diode action, generally it is a VA and VK. VK. Where it is connected? It is a VR. It is connected to VK. Now you have to understand, you have to apply the VA voltage should be greater than the VK voltage. But VK was not 0 right now. VK was connected with the reference voltage VR. So it should be applied at the VA much greater than the VR. Then only diode will become forward bias. Otherwise, diode is not conducts. It is will become open circuit only. So that I stated, VI, if it is greater than VR, then diode will become something like a short circuit. And V0 is equal to 0 or VR. What's the voltage? Means it is going to be equal to the VR only. Why? Because when diode is on, this diode will become short circuited. That VR is going to be acting like a V0. Next point. When Vi is less than VR, then D is going to be half. is going to be acting like open circuit, then V naught is equal to means when diode is off, V naught is equal to Vi. Simple. When diode is open, could you consider this VR? No. It is open already. This V naught is going to be consider this Vi. Like output. What are the transfer characteristics of this one? Very simple. Transfer characteristics. You have to understand transfer characteristics, then we can draw it. It is Vi. We have the V naught. VR, positive VR, negative VR, this one positive VR. Then we can keep this one. It is positive VR. Up to positive VR, diode in reverse bias. After positive VR, diode is in forward bias. You should see this one. When Vi is greater than VR only, then only you will get output is VR. Until that VR, input voltage, if it is available, then output voltage is equal to Vi only. Then you should understand first point. If Vi is greater than VR, now at this point you have to observe. Now Vi is greater than VR. What is output? It is going to be VR only. Output is VR. This means when Vi is greater than VR, output is VR. When Vi is less than VR, output follows the input. Vi is less than the VR, output follows the input. What is this one? It is nothing but V naught is equal to V. This is transfer characteristics of your diode. When you have the reference voltage, how the input and output waveforms behave. This one is Vi. Then we can have this one VR. Then we can draw the output. Yeah. This one is for positive, this one is for negative. Now how do we consider the reference voltage? This one reference voltage. Because now the tripping of the conduction of the diode will be considering the reference voltage, not zero crossing. Yeah, just we have to understand this portion. It is less than VR. What is output? Its output is follows. Let me consider here also, like you know, this VR. Before this place VR, output follows the, because now input voltage is less than the reference voltage. When input voltage is greater than the reference voltage, output maintains the reference voltage. Then when you consider again, once you cross this reference voltage, next voltage follows that one, Vi is less than R. So the output follows input. What about the negative peak voltage, negative off cycle? It falls in the second condition, Vi is less than VR. There you could be considered that output follows the input. Here, this one is the transfer characteristics. This one is the output and input voltage relationship. What the portion was clipped off? This portion. Here, this portion was clipped off with the reference voltage plus VR. You can also draw the circuit, like you know that one by changing the polarity of this minus VR. Here in the sense, you have to understand when the diode is going to be conducted, when diode is not going to be conducted. Very simple understanding. Vi greater than minus VR. It is enough to have the diode will become conductor and acting like a short circuit, and output follows minus VR. When you consider Vi is less than minus VR, diode will become off. It will be acting like a short circuit. Now V0 is equal to again Vi. Now you can withdraw the transfer characteristics for this. Very simply. Here we have the reference voltage minus VR. Then you can draw like this. Again you can be taking this over the x-axis is Vi, over the y-axis is V0. You are taking the V reference is negative. So you should understand the negative V reference voltage. First condition, when VA is greater than minus VR, output is follows the only reference voltage. Means what? Minus reference voltage. You should understand. This one is the output terminal, negative, and this is a voltage when VI is greater than the minus VR. After minus VR, what we get? Positive of cycle. Up to this is following the minus VR voltage only. Then Vi is less than minus VR. Then D will become off and it is acting like a short circuited. Output follows the input. Means this is the output follows the input. Because Vi is less than VR. Now we have to understand how do you consider this. Vi is less than minus VR. Let me consider my VR is nothing but minus 1 volt. What is the next volt here? Minus 2, minus 3 volts, minus 4 volts. You have to be considered minus 2 volts, minus 3 volts is more negative than the minus 1 volt. So you should be understand minus 2 volts is lesser than the minus 1 volt. So you should be consider VI is less than minus VRV. VI may be having this minus 2 volts, minus 3 volts, minus 4 volts. Then you should be understand this is going to become off and it's acting like open circuit. Then V0 is equal to VF. This is it should be understand. And what about this input output waveforms? You can draw corresponding to this. Very simple. Again, how to draw like this T and have the positive cycle, negative of cycle. We have this one is the Vi and reference voltage is in the negative polarity, so it is minus Vi. And again, you should take one more. Here you should be considered 2 points. Vi is greater than VR. VR is here minus VR. Then Vi is greater than VR minus VR. Then V0 is following the minus VR only. Just you have to understand up to this point. This one is the minus VR. This one is the zero crossing of the positive cycle. This one is the minus VR again. This one is the zero crossing of the negative cycle. Until this point, yet diode will follow the minus VR only. Now you consider this one. Vi is less than minus VR. Here it means that once you consider, then input voltage is less than the minus VR. This one is the point where you can trace out this minus VR is going to be available over the input. Then Vi is less than minus VR. This total portion is less than minus VR. So in this portion, output follows the input. Very simple, like this. Why can't you extend this line up to this zero crossing in? Here at this point again you can be consider now minus VR is there here up to this point, but now Vi is less than minus VR. When you consider Vi is minus than so Vi is greater than minus VR, then you have to consider the first condition. When Vi is greater than minus VR, V0 is equal to minus VR. Then it is following like this, not to be extended to the zero crossing. This one is the different variety of circuits you can be understand by changing the polarities of the diodes as well as the reference voltages. Thank you everyone. We will continue. Next topic is series clippers with the reference voltages and some other configurations. Thank you everyone.